This is the picture we're going to use for both questions 7 and 8. So question 7 asks, if the consumer's income is 2,400 Rand, what are the prices of products X and Y? So this is a similar approach to the question in A1, except in A1 we told you what her total budget is and we told you the price of one of the products. Now we're only giving you the income and we're asking you for both prices. But the reason why we don't need to give you at least one price is because we've given you these two intercepts. So the important part of the theory that we need to use here is the knowledge that those intercepts represent what we call real income, which essentially is the affordability of an individual consumer. And that is income divided by the price of a product. So it could be product X, or it could be Y divided by the price of product Y. Because essentially, our income is always defined in terms of what we can actually buy with that income. So when we talk about real income in the general economy, and this is something you'll cover in macroeconomics, what we mean by that is we adjust everybody's income for inflation. And inflation is just simply a collection of prices. Inflation represents an aggregate price within the economy. So in microeconomics, when we talk about real income, we're saying how much can your income buy you in terms of one product. And that's what these intercepts represent. So this intercept here of 160 tells us that if the consumer spent all their money on product Y, they would be able to buy 160 units of product Y. So that 160, which is real income, is the same as 2,400 divided by whatever the price of Y is. So if I just rearrange this formula, I'll get the price of Y is equal to 2,400 divided by 160. And that will give me a price of 15 Rand. Okay, so the price of product Y is 15 Rand. If we go down to the answers, only one of the answers here satisfies the price of Y being 15 Rand. So I can automatically say that the answer is C, because none of the other prices, or none of the other options A, B, or D has a price of 15 Rand. So that's quite nice because you only have to do one calculation. But sometimes you might get a question where two answers would have price Y equals 15 Rand. And that means you then have to also figure out what the price of X is. So if we also needed to know what the price of X is, then we would do exactly the same sum as we did there. We would say the price of X is equal to 2,400. But now instead of dividing it by 160, we divide it by 200 because that's the amount of X that we can buy with all our money. So that tells us that X costs 12 Rand. And if we go back to C, that's exactly what we get. The price of X is 12 Rand and the price of Y is 15 Rand. Okay, so sometimes one answer will very obviously be correct without you having to do both calculations. But just know that we won't necessarily only have one answer that is clearly correct. There may be another answer that is half correct, half wrong, and then you might have to do both calculations. Okay. So then if we go to question 8 then asks, why does the consumer not choose the combination at point B? So the reason why B is not chosen is because B is not a consumer equilibrium. And the reason why B is not a consumer equilibrium is because it does not satisfy a very important condition. And that condition is that the marginal rates of substitution must be equal to price of X divided by price of Y. What we mean by that is that your indifference curve slope must be the same as the budget line slope. Okay, so margin rate of substitution is the slope of your indifference curve, whereas the price of X over the price of Y is the slope of your budget line. The reason why this is consumer equilibrium actually relates back to chapter 8. So yesterday we talked about a question where we needed to show that marginal utility of x divided by the price of x should be equal to the marginal utility of y divided by the price of y. So that's the one condition for consumer equilibrium. A second condition for consumer equilibrium is that the consumer must spend all their money. So these are the two conditions that any consumer has to satisfy in order to maximize total utility. So we know that B is spending all money because it is on the budget line. So whatever the consumer is spending at B is everything the consumer has. They're spending 2,400 Rand. However, this first condition doesn't hold. And the reason why I can say that is because if I rearrange this formula, MUX over PX equals MUY over PY, I can take the MUY to the left-hand side of the equation, and I can take the PX to the right-hand side of the equation. So I can rewrite this as MUX over MUY equals PX over PY. And the marginal utility of x divided by the marginal utility of y is the marginal rate of substitution. So in actual fact, when you have a point of tangency between the indifference curve and the budget line, that is exactly the same as saying that the marginal utilities per rands are equal. Okay? So this needs to be true in order for the consumer to be in equilibrium. If we look at this point B here, we can see that the budget line cuts through the indifference curve. It doesn't lie tangent to the indifference curve like it does over here. And the reason why we then can say that this doesn't represent a marginal consumer equilibrium is because the slope of the budget line is very clearly steeper than the slope of your indifference curve. So what we know from this picture here is that at B, the marginal rate of substitution is currently less than price of x divided by price of y. The budget line is steeper than the marginal rate of substitution. And that is the reason why it doesn't represent a consumer equilibrium. The opposite is true of A. If I look at point A, now I can see the indifference curve is steeper than the budget line. So at A, the opposite is true. At A, the marginal rate of substitution would be greater than the price of x over the price of y. So in terms of our choice of answers, what we have is, why does the consumer not choose the combination of point B? A says the marginal utility per rand spent on x exceeds the marginal utility per rand spent on y. So if we go to this condition here, if the marginal rate of substitution is less than px over py, I could rewrite that as MUX over MUY is less than PX over PY. And then if I just swap where the price of X is and where the MU of Y is, so I take PX to this side and MUY to that side, I get MUX over PX is less than MUY over PY. So what that tells me is that actually at point B, the marginal utility per rand of X is smaller than the marginal utility per rand of Y. So A is not correct, okay? Because A says that the marginal utility per rand spent on X exceeds, but actually what we've proven is that the marginal utility per rand spent on X is less than the marginal utility per rand spent on Y. So the answer A is incorrect. So what we then know is that we need to go to B. So B says a consumer is willing to give up more Y for an additional unit of X than must be given up given the relative prices of X and Y. C says the marginal utility per rand spent on Y exceeds the marginal utility per rand spent on X. And D says both A and C. Now D can't be right because we've already proven that A is wrong. So D is wrong because A is wrong. So now we only have to choose between B and C. We've already actually shown that the marginal utility per rand spent on Y exceeds the marginal utility per rand spent on X. So C is correct. We then have to judge whether or not B is right or wrong, just to make sure that C is correct. So B says the consumer is willing to give up more Y for an additional unit of X than must be given up given the relative prices of X and Y. This is the same as saying that the marginal rate of substitution is greater than the relative prices. In other words, the indifference curve is steeper than the budget line. And if we go back to the picture, that is the opposite of what is true at B. B has a steeper price ratio and a flatter marginal rate of substitution. So B is incorrect because B is actually describing what is happening at A. Okay, so the answer to 8 is answer C. So in this example, the market is trading off Y and X according to a ratio of 12 Rand to 15 Rand. Whereas you, the consumer, are always changing how you trade the two products off. It just depends on how much you have of those two products. So when you have very little X, so let's say you're down here on X and you have a lot of Y, your marginal rate of substitution is very steep because when you have a lot of X and a lot of Y and very little X, you're willing to give up Y because Y doesn't have as much value to you because you have a lot of it. But as you start to consume more X, and consuming more X means having to give up Y, your marginal rate of substitution starts to fall. And that's why the indifference curve becomes flatter, because as you have more X and less Y, X starts to become less valuable to you, but Y becomes more valuable to you, which means you're less willing to trade off Y for X. So understanding what this graph represents in terms of consumer behavior is really important for doing these kinds of questions in an assessment. So then we'll go to question 9. So question 9, I'm just going to mention what question 9 is about. We're not going to get the answer yet because what I want to do is go to question 10, because in question 10, I can actually then show you the movements that reflect the substitution effect and the income effect. So question 9 says, the substitution effect of a price change is shown by the movement from the original best affordable point to the new best affordable point. So if we have to go to the picture in question 10, what we mean by that statement in 9 is that the movement from A to C is the substitution effect. It actually turns out that the movement from A to C is a price effect. If we look at this picture, what we can see is that the budget line has moved outwards. So whereas the original budget line cut milkshakes at 4, it now cuts the milkshake axis at 8. And that tells us that the price of milkshakes went down. And the reason why I can say that the price of milkshakes went down is because the further that intercept is from the origin, the larger the consumer's real income. So the price of milkshakes from this graph fell. And in actual fact, because it went from 4 to 8, in other words, consumption of milkshakes using all the money doubled, that tells me that the price of milkshakes actually halved. So this is the kind of information you can get from those intercepts. So the real income of this consumer has increased. And that's because milkshakes are cheaper. In terms of soft drinks, nothing has happened. The fact that the intercept for soft drinks is still 8 tells us that something happened to the price of milkshakes, but nothing happened to the price of soft drinks, because this consumer's real income in terms of soft drinks is exactly what it was before. So the graph below shows this consumption of soft drinks and milkshakes. The question then tells us Jack has a weekly income of 8 Rand and his optimal consumption point is point A. So we're starting off at point A on the picture. So I'm just going to circle that. So that's where we're starting off. The question then says, calculate the prices of cool drinks and milkshakes respectively. So this is identical to question 7. We get given income and they ask us for the 2 prices. So what do we use? We use the 2 intercepts, 4 and 8, in order to get the price of milkshakes and soda. So the price of soda is going to be 8 Rand income divided by 8, which is the amount of soft drinks or cool drinks that this person is consuming with all their money. So a soft drink is 1 Rand each. For milkshakes, price of milkshakes will be 8 Rand income divided by 4, which is his current consumption of milkshakes. So the price of a milkshake is 2 Rand. So that would be the answer to question A. Cool drinks are 1 Rand each and milkshakes are 2 Rand each. Question B then says Jack's optimal point of consumption now moves from point A to point C. What would have caused this change? So Jack has moved from A to C. And we've already actually discussed this. The reason why his consumption bundle in equilibrium has moved from A to C is because milkshakes have become cheaper. And that has caused the budget line to shift outwards along the axis for milkshakes. But nothing has happened to soft drinks. So when you have a change in one of the intercepts and the other intercept remains the same, this had to have been caused through a change in price of the one product. If both intercepts had changed, that would indicate either that income changed and prices stayed the same, or income stayed the same and both prices changed, or even income could change and prices could change. So these budget lines can move for various reasons. In this case, however, it is simply a result of milkshakes becoming half as expensive. So instead of milkshakes being 2 Rand, using the new budget line, we can see that the new price of milkshakes is 8 Rand divided by 8. So milkshakes are now 1 Rand each. Okay, so that's what caused the change in consumption from A to C. Part C then says, are milkshakes a normal or inferior product? Explain your answer briefly with reference to the graph above. When we ask you with these pictures to characterize a product, we're usually asking you to characterize it in terms of whether it's normal or inferior. And the way we see this is through the income effect. So I'm going to go back quickly to question 9, because what I'm going to show you is how the substitution effect looks on the graph, how the income effect looks on the graph, and then how these two effects together give us the price effect. So the substitution effect is this idea that when the price of one product changes, that means the consumer is going to change their consumption away from the relatively more expensive product towards the now relatively cheaper product. So when the price of milkshakes went down, this means, I'm going off the page, this means that milkshakes are now relatively cheaper. So the consumer, which in this case Jack, is going to substitute soft drinks for milkshakes. Okay, so that's the substitution effect. The substitution effect says if something changes in price And that then changes the relative cost of products. The consumer, who is rational, will then substitute towards the now relatively cheaper product and away from the now relatively more expensive product. So what I mean by relatively cheaper and relatively more expensive is before milkshakes became R1, it was the case that if you bought a milkshake, you had to give up 2 sodas. Now, if you buy a milkshake, you only have to give up 1 soda. So that means milkshakes have become relatively cheaper. In relative terms, you don't have to give up as much as you had to before. Previously, if you bought a soda, you would have given up half a milkshake. But now that milkshakes are only R1, every time you buy a soda, you have to give up a whole milkshake instead of half a milkshake. And that tells me that soda has now become relatively more expensive. So the substitution effect would say, buy more milkshakes and buy less soda. In order to identify the substitution effect on this picture, what we do is we look at the new budget line, which represents the new relative prices. So the slope of the new budget line tells us what is the opportunity cost that this consumer now faces. And what we do is we take that new budget line and we move it back towards the original indifference curve. And we find the point where this budget line is just tangent to the original indifference curve. And that turns out to be at point B. So the movement from A to B is the substitution effect. Because what it tells us is that because milkshakes are relatively cheaper compared to sodas, I will substitute sodas for milkshakes. So I will buy more milkshakes and less soda, whilst at the same time making myself as happy as I was before. So that's what the movement from A to B represents. It says you face new prices, however, you want to change your consumption in such a way that you don't create a worse situation for yourself. You try to make sure that you maintain your same level of happiness. Okay, so A to B is the substitution effect. Once you're there at B, so once you've managed to satisfy your original level of satisfaction, now you realize, actually, I have money left over. I'm inside my new budget line. So I can actually afford to be more satisfied. I can actually afford to move from this point here onto a higher indifference curve. And that movement from B to C is the income effect. So that positive change there is the income effect for milkshakes. And this is the effect that we then use to define the normal or inferior status of our products. So because the income effect is positive, and because a lower price has meant I'm now relatively wealthier, this tells me that milkshakes are normal goods. Because now that I have more money, I buy more of this product. So the answer to C is milkshakes are normal. And in terms of explaining your answer briefly, what you would say is that milkshakes are normal products because the income effect, the movement from B to C in the graph, is positive for an increase in real income. So this for me is a perfect answer to this question because it's hitting all the right notes with regards to your economics. So you're saying, I know how to identify whether it's normal or inferior. I need to look at the income effect. But more than that, I actually know how to read the income effect off the picture. It's the movement from B to C. And I also know how to define a normal product. A normal product is a good that when income goes up, you buy more of it. So this answer incorporates everything that is necessary to understand the income effects in these indifference curve and budget line graphs. So to go back to question 9, where it says the substitution effect of a price change is shown by the movement from the original best affordable point to the new best affordable point, which in this picture would be from A to C, we can now see that that isn't the substitution effect. Okay, the substitution effect is shown by the movement from the original best affordable point to a point on our original indifference curve, but represents the new prices we face. What 9 is actually describing is the price effect. So if this question or this statement had said the price effect is shown by the movement from the original best affordable point to the new best affordable point, yes, then by all means it would be correct. But this isn't describing the substitution effect, and that's why the answer to 9 is false. So the price effect is your complete change from the old equilibrium to the new equilibrium. So the price effect is your substitution effect plus your income effect. So the movement from A to C is the movement from A to B plus the movement from B to C. Can you please re-explain how you work out the opportunity cost of goods on the budget line? Does the graph in question 10 tell us in simple terms, and why do you draw the stipple line? Okay, so opportunity cost is what you have to give up. So if we go to question 7, if I think about these two products, Y and X, every time I buy a unit of Y, I'm having to spend 15 Rand. When I make that decision to buy 1 unit of Y and spend 15 Rand, I am necessarily making a decision not to buy something else. And in this case, that something else is X. So when I buy product Y, I'm using 15 Rand on Y, and that 15 Rand could have been used to buy 1.25 units of X. So I can work that out using the formula relative price of Y, which is the same as the opportunity cost of Y, is the price of Y divided by the price of X, which is 15 over 12 Rand, which gives me 1.25 X. So every time this consumer chooses to buy a unit of Y, they are foregoing the opportunity to buy 1.25 units of X. And then the same is true in reverse. In reverse, what it means is that if I choose to buy a unit of X, I'm necessarily giving up some Y. So the relative price of X is equal to the price of X over the price of Y, which is 12 Rand over 15 Rand, which is 12 divided by 15, 0.75 Y. Is that correct? I need to double check my maths, but I think it's correct. No, 0.12 divided by 15, 0.8. Yeah, it's a good thing I checked that. Okay, so every single time I purchase a unit of X, I am giving up 0.8 Y. So relative price is the same as opportunity cost. So relative price equals opportunity cost equals the slope of the budget line. So sometimes we've asked questions before where we ask, what does the slope of the budget line represent? And you can argue that the slope of the budget line represents the relative price of these products, which is also the same as the opportunity cost that the consumer faces every time they choose to buy one product and not another product. So that's how the budget line relates to opportunity cost. I just want to remind myself of the other question. Yes, what does the graph in question 10 tell us in simple terms, and why do you draw the stipple line? Okay, so what the graph in question 10 represents what the graph in question 10 represents in simple terms is it represents consumer behavior. What it tells us is, how does a consumer get from one consumption point to another consumption point when there is a change in price? That is basically the idea behind the demand curve. If prices change, our quantity demand change. So this graph here is essentially what underlies any demand curve. And the point of this theory is to try and then prove that if prices go down, quantity demanded goes up, which we can very clearly see on this picture. Because the price of milkshakes has gone down, the quantity demanded of milkshakes has gone from 2 to 5. So the price effect is what we see on a demand curve. The demand curve doesn't show us the substitution and the income effect. It only shows us that price effect. So this graph allows us to then break that price effect down into a substitution effect and an income effect. And that's what the stipple line is used for. This stipple line represents the new prices. So the new budget line is given because milkshakes became cheaper. And that stipple line has the same slope as the new budget line. So the stipple line, when we move it back towards I1, the original indifference curve, what we're trying to find is, at what point would this consumer achieve equal satisfaction as before, but facing new prices? And that's what the substitution effect is about. It's about the consumer changing their consumption behavior because things have become relatively cheaper or more expensive, but at the same time, you want to stay as happy. You don't want to sacrifice your happiness because you now are changing your consumption choices. Once you meet that condition, once you've faced a substitution effect, that's when you realize, hang on, I actually have money left over. I've managed to make myself as happy as I was before through changing the amount of milkshakes and soda I drink. But it turns out I could actually be happier. I can consume more. And that's what the income effect represents from B to C. So the whole idea behind this graph is to show where the demand curve comes from. Please, may you show us how the graph would look in reverse? Yeah, I can do that. You can do it. You've said, so if you were asked the opportunity cost at a point on your budget line, would it be specified if it's relative to product X or Y? Yes, most definitely. Now, because the budget line slope would be calculated using whatever is on the y-axis as the base and whatever is on the x-axis as the actual price we're interested in, typically, when you calculate the opportunity cost represented by this budget line, you would take the price of what is ever on the x-axis and divide it by the price of whatever is on the y-axis. And the reason why that is the case is because if we just go back to the formula we did yesterday for the budget line is represented as the quantity of Y, which in this case is soda, equals income divided by the price of the product on the y-axis minus the price of the product on the x-axis divided by the price of the product on the y-axis times the quantity of the product on the x-axis. So this is the general form of the budget line. And the slope is given by price M over price S. And price M over price S is the relative price of a milkshake. So it depends on how the graph is drawn. So if we ask you what is the budget line, what does the slope of the budget line represent, you would say it represents the relative price of whatever product is plotted on the x-axis. And that would be the answer for that question. Let's say that this picture was actually drawn for a price decrease. No, not decrease, sorry, increase. So let's say that you were told, so I'm going to try to look for a blank space where I can draw. Otherwise, what I'll do is I'll just delete these arrows quickly, and then I'm going to show you how it works in reverse. Okay. And this is why it's actually good to understand the theory, because what happens sometimes is we will give you letters A, B, C. Don't ever take it for granted that the movements are going to be in that order A, B, C. Sometimes it can be C, B, A, which is what I'm going to do now. Okay, so I'm just going to delete just the arrows. Okay, so let's say that this consumer started at C. So the place where the consumer started was at this consumption point here. So I'm going to label it point 1. And then the price of milkshakes went up. So the price of milkshakes doubled. And the budget line then swiveled inwards along the axis. Okay? Now, B actually won't represent anything, because when you move from this budget line to that budget line there, it means that the new relative prices you face are represented by the slope of the new budget line. So in order to find the substitution effect, I would have to take the slope of the new budget line and move that back towards the original indifference curve. And I would have to find a point where that line becomes tangent to the original budget line. Sorry, original indifference curve. So that could be something, and I know this isn't going to look great because I'm going to try my best to draw this straight. So you would have a stippled line that would have the same slope as the new budget line, but it now lies tangent to the old indifference curve. So let's say it's a point like that. So this is now point B. So what we've done by moving from C to B is we're saying milkshake is now more expensive. So as a rational consumer, I would then choose to buy fewer milkshakes and more soft drinks whilst trying to keep myself as happy as I was before. So that movement from C to B is the substitution effect. It's saying prices have changed, and that's what kind of looks like a stippled yellow line, but I mean the drawing is not perfect. So that stippled line that is tangent to the old indifference curve. So that's my substitution effect. Once you get to this point here, you've maintained the same level of satisfaction that you had before, but now you are outside your new budget line. So B, even though it makes you as happy as you were before, once you've changed your consumption of milkshakes and soft drinks, it's actually not affordable. Because milkshakes have become more expensive, you are now relatively poorer. So that means you can't stay at B. It's not affordable. You now need to move onto a point on your new budget line that is just tangent to the highest attainable indifference curve. And that is point A. So the movement from C to B would be the substitution effect. So C to B would be the substitution effect, and B to A would be the income effect. And the movement from C to A would be the price effect. So that's how it works in reverse. So the first question is a true and false, and it says street lights are a public good. Therefore, there is no incentive for a private company to provide street lights. So the important thing to recognize in this question is that statement, public good. Street lights are a public good. What does that mean? It means that street lights are non-rival and non-excludable. What we mean by non-rival is that one person's consumption of the good or service does not prevent someone else from simultaneously accessing the good or service. So if something is non-rival, that is the same as saying it's not competitive. There is no competition involved. If I'm consuming the product, that doesn't mean you can't consume the product. We can all consume it at the same time or at relatively the same time. Excludable, so non-excludable means that there is no constraint in the form of price that prevents a consumer from benefiting from using the good or service. So when things are non-excludable, it means basically you don't have to pay for it. So street lights, you don't have to pay for every time you use them. We pay for these things indirectly, which we'll talk about a bit later in another question. So street lights are something that when you walk under them, you're not having to pay for that service. It's just provided to you. Also, if I stand under a street light, that doesn't mean you cannot stand under that same street light. We can both benefit from the light provided at the same time. So because public goods are non-rival and non-excludable, it means that many people will end up accessing this product without paying for it. And private companies need to receive some kind of profit incentive in order to provide a product. So if we are using this product and we're not paying for it, private companies won't provide it because they won't be able to get anything back from us in the form of price in order to cover the cost of providing it. So the answer to this question is true. Okay. If the question was describing a private good, then most definitely there would be an incentive for a private company to provide it, because private goods are rival and excludable, which means in order for you to access it, you have to pay for it. And when you're having to pay for something, firms are then able to cover the cost of providing it. And therefore, there would be an incentive for them to provide it to society. Okay, so the answer to 1 is true. Question 2 then says, discuss the free rider problem with respect to the provision of public goods. And how might the free rider problem be solved? So this essentially involves what we just mentioned above. So the free rider problem results from the fact that public goods are non-rival and non-excludable. This means that consumers are able to benefit from using the good or service without having to pay for it. This means that the private sector would provide an inefficient underproduction of the good or service. How might this problem be solved? The problem is solved through public government provision of the product or service, and it would be paid for indirectly through taxation. Okay, so the free rider problem is something that exists only for products that are non-rival and non-excludable. And because these types of products do exist in society, private businesses would not provide them. Government has to provide them, and they do so through collecting taxes, and that tax income is then used to pay for the provision of these goods and services. Okay. Question 3 then asks, you're studying with a friend, and your friend says private goods are excludable and non-rival, while public goods are non-excludable and rival. Do you agree? Explain fully. So there are 2 ways that students could have answered this question. The one way you could have answered this question is to say, well, are private goods excludable and non-rival? No. Private goods are, yes, excludable, but they are rival. So no, I don't agree, because private goods are excludable, but they are rival. And public goods are non-excludable, yes, but they are non-rival. So this statement that is being made is wrong for 2 reasons. It's wrong because private goods are not non-rival and public goods are not rival. So this person has gotten the rival part the wrong way around. The other way you could have answered this question is to say, no, it is actually natural monopoly goods that are excludable and non-rival, and it is common resources that are non-excludable and rival. So those are 2 perfectly acceptable answers to this question. The first one just changes the words that are used to describe the good. The second answer changes the good that the 2 characteristics describe. Because those are the 4 types of products we operate with. We have private goods that are rival and excludable. We have public goods, which are non-rival and non-excludable. We have natural monopoly goods that are, not non-trivial, non-rival. We have natural monopoly goods that are excludable, you have to pay for them, but they are non-rival because when you use these types of goods and services, it doesn't limit the potential for someone else to simultaneously access the product. So an example of this is the internet, or Netflix, or iTunes. So those are all natural monopolies. And then common resources are non-excludable. Anyone can access them, but they are rival. So when you consume a common resource, it now limits the amount that is available to everybody else. So the example of this is wildlife, a park bench. Okay, so you don't have to pay to sit on the park bench, but if you're sitting on the park bench, somebody else can't sit on the park bench. Okay, so what I'm going to do is go on to the next set of questions. So the next set of questions, this question here is also linked to chapter 16, but we also use this theory in chapter 17 when we talk about efficient provision, where we have marginal benefit and marginal cost coming together in a market. This question just illustrates the fact that whereas market demand, which is marginal private benefit, we get by horizontally adding up individual demand curves, a marginal social benefit curve we find by vertically adding up marginal benefit curves. And the reason why marginal social benefit comes from vertically adding demand curves is because when you provide this service, such as the police, it's a public good. What it means is that Pierre and Andile will have their own value attached to police cars. But when we provide these police cars, it's not that Pierre only has access to it and Andile doesn't. They both have access to this good because it is public. So that's why marginal social benefit differs from marginal private benefit, because it's something that is socially accessible. Everyone can derive benefit from it, irrespective of whether you are directly or indirectly paying for it. So in this question, we give you the marginal benefits of Pierre and Andile for police cars, and we assume that they're the only two people in this economy. So this is an economy of two people. If the marginal social cost of a police car is 115 Rand, what is the efficient number of cars? So efficiency we define as marginal social benefit being equal to marginal social cost. So the efficient outcome, the efficient outcome in any market is where MSB equals MSC. The marginal social cost in this example is constant. It's always 115 Rand. When we have one police car, it's costing 115 Rand. When we introduce a second police car, that second car has a marginal cost of 115 Rand. The third police car, a marginal cost of 115 Rand, and so on and so on. So the marginal social cost is constant at 115 Rand, but the marginal social benefit is going to be the value or the benefit that these two consumers place on each police car added together. So when one police car is provided in this society, Andile gets 90 units of benefit, whereas Pierre gets 50. So Pierre would be willing to pay 50 Rand for this police car to be provided, whereas Andile would be willing to pay 19 Rand for this police car to be provided. So if the police car is provided, the total marginal social benefit in this society would be 140. If two police cars are provided, the total marginal social benefit of the second police car would be 115. The third police car would have a marginal social benefit of 90. The fourth police car would have a marginal social benefit of 65. And the fifth police car would have a marginal social benefit of 40. So those are the marginal social benefits. And we can see that the more police cars that are provided, the lower the marginal social benefit. And that's basically reflecting a downward sloping demand curve. If we want to find out where will the market be efficient, we need to compare this marginal social benefit to the marginal social cost of 115 Rand. And we see that marginal social benefit will be equal to the marginal social cost at 2 police cars. So the efficient number of cars in this society of 2 people is 2 police cars. Okay, so this is a very, very basic example of what I'm going to do next. Which one of the following is an example of a positive externality? So the first thing to know is, what is an externality? So an externality is a cost or benefit that falls onto someone other than the private producer and or private consumer of the good or service. So a positive externality could be a positive consumption externality, which means when you consume a good or service, you indirectly create a positive outcome or a benefit for someone else who wasn't directly involved in that consumption. So the classic example of a positive consumption externality is education or vaccinations. When you get vaccinated, it means that because you're not getting sick, people around you won't get sick. So they don't have to get vaccinations because you aren't getting sick, so they won't get sick. If you are being educated, then you can share that education with other people, even though they aren't paying for it. A positive production externality is when the production of a good or service indirectly benefits someone else who wasn't directly involved in the production of that good or service. It can be quite tricky to think of examples of positive production externalities, but one example that I think makes a lot of sense is, for example, if you have a honey farm next to a flower farm. So if you have a lot of beehives and they're located really close to a farm that is growing flowers, then actually you are able to indirectly benefit from each other because the bees will pollinate the flowers. And if the flowers are, for example, lavender, that can then flavor the honey. So there is a positive production externality that can result from that kind of arrangement. So the answer to this question, which one of the following is an example of a positive externality, is D. So D is the example I just mentioned just now, a benefit to society that arises from young people acquiring more education. So there are many positive externalities to people becoming educated. It has positive effects on social issues such as crime. Basically, it just creates a society that is more cohesive, a society that is more understanding, a society that has more equality because education definitely uplifts everybody. So question 6 asks, what do positive externalities result in? So positive externalities mean that there is an external benefit. So positive links to benefit. It's benefiting someone. It's a positive thing. Externality means it's external. It's being experienced by somebody else other than the person who is actually consuming the product. So if we think about education, for example, which brings positive externalities. So we have the price of education, and we have the quantity of education, and we have a demand curve, which is the private marginal benefit curve. So what the demand curve represents in this case is the benefit that is being extracted by those who are actually paying for the product. Okay? So education is a mixed good because it's private in the sense that you have to pay to be able to attend class. Okay? So in that case, it's excludable and it's rival. Classes are limited in size. So those who are able to afford the tuition, they're the ones who access the space, and we only allow enough people that the space can take. Okay, so education fulfills the definition of a private good. It is rival and it is excludable. Why it is then a mixed good is because even though it is private in those characteristics, it creates positive externalities for society. So there is a marginal external benefit. So the other name we give for positive externality is a marginal external benefit. Every time education is consumed by somebody who is privately paying for it, they are able to indirectly benefit others who weren't in that same classroom. So the marginal social benefit curve lies above the marginal private benefit curve. And this marginal social benefit curve is the marginal benefit curve plus that marginal external benefit. So if you choose any points on the marginal social benefit curve over here, and you move down towards the demand curve, that distance there is the marginal external benefit for this amount of education. Okay. And what we can see is that, generally speaking, as more people become educated in society, that external benefit gets smaller and smaller. When there are very few people who are educated, there are huge external benefits to be had from educating more people. But as society moves closer to being universally educated, the external benefit gets smaller and smaller. So that's the marginal social benefit and marginal private benefit curve. These then have to come into interaction with the supply curve. And the supply curve, without any marginal external cost, is the same as the marginal social cost curve. So the supply curve in this example is the same as the marginal social cost curve. If the market was just allowed to operate as normal, the market wouldn't take account of these external benefits because the market isn't feeling it. All the market is aware of is the benefits to students and the costs to schools. Okay? So the market is only going to take account of marginal private benefits and marginal private cost, which in this case is the same as marginal social cost because there are no negative externalities. So this is where the market would be. It would be where demand and supply intersect. The market, however, in order to be efficient, would need to be here, where MSB equals MSC. So this would be the efficient outcome. So the result of a positive externality in a market is the amount that the market provides, which is given by that green stippled line, is smaller than the quantity that, the quantity the market should be producing to be efficient is larger than what the market is actually producing. So the problem with a positive externality is that if the market doesn't account for this positive externality, it leads to inefficient underproduction. So that's the answer to question 6. If there were no positive externalities, then the efficient quantity would be produced. If there were negative externalities, then there would be inefficient overproduction. D is incorrect because externalities do have effects on the market. Externalities, if they are not accounted for, result in a market failure. And a market failure means that because there is either under or overproduction, we will end up with a deadweight loss. So without taking a positive externality into account, these markets would underproduce, leading to a deadweight loss. Okay. So question 7 is exactly the same. It says, in an unregulated competitive market, the presence of a marginal external benefit and a marginal external benefit, as I just mentioned, is the same as a positive externality. The presence of a marginal external benefit from a good or service results in inefficient, and here is where reading becomes really important, because here it says it leads to an inefficient overproduction. But what we've just seen from the graph above is that a positive externality or a marginal external benefit actually leads to an underproduction. So the answer to this question is false. Is the green E a quantity that should be produced but isn't? Yes. So the green E represents the efficient outcome. It represents the allocation efficient point. It's where society would need to be in order to maximize total surplus. Because this market doesn't account for the positive externality unless it's regulated, that means it underproduces, and that's why it creates a deadweight loss. So we're losing surplus through not acknowledging the positive externality from this product. What would happen if it was a regulated market? So that's why we have regulation. Regulation exists in order to account for these externalities. Because if we don't account for these externalities, we end up underproducing or overproducing and then creating a loss in total surplus through a deadweight loss. So if this market was regulated, so let me just draw this. So I'm just going to repeat the graph from above. So we have demand and we have marginal social benefit, which lies above demand because it accounts for the externality, and demand is the same as the marginal private benefit of providing this good. Okay. Oof. For some reason my pen is deciding not to work. Okay, so we have demand is equal to marginal private benefit. And then we have supply, which is the same as marginal social cost, which is the same as marginal private cost, because we're going to assume that there are no negative externalities. So this is where we want the market to be. We want the market to be at this point here, where MSB is equal to MSC. So we would want this quantity to be provided in society, because this is the quantity that is going to maximize surplus. If the market is just left to its own devices, it's going to produce here. So it's going to underproduce, and that's going to lead to a deadweight loss. Now, for us to get the market to here, what we have to acknowledge is that it's going to cost more to provide this good. So in order to provide this quantity of the good or service would require having to charge a higher price. Because at the current unregulated market outcome, price is lower and quantity is lower. So this is the whole thing. Getting the economy or getting this market to the efficient point means a higher cost, because you can't produce more without it costing more. And the problem then becomes that at this quantity, it costs this much. But remember, the demand curve represents the value of this product to those who are actually consuming it. So this quantity is only valued at this amount here. This is the marginal benefit that people place on that unit. So this is the conundrum. The conundrum is, we want this quantity, it's going to cost a lot more to provide it, and those who are using it are only able to pay this amount. So this is where regulation comes in. Regulation says, in order to provide this quantity, we can only charge private users this price, and then this difference here has to be paid by somebody. And it is this difference here that would be paid for by taxation. So what would happen is government would have a tax that is not falling within this market. It's a tax that is maybe applied to income, but then part of that income tax that is collected is then distributed within society in order to cover this higher cost of providing this good that provides a positive externality to society. So either that tax could be used to subsidize whoever is providing this product. So if it's education, for example, government could then give subsidies to schools, or this tax could be used to give grants to households. So instead of giving the money to the private producer to make it cheaper for them to provide this product, the government can give the money to the private consumer to make it possible for them to pay this higher price. So this difference here is the amount that then needs to be covered through regulation. Okay, so question 8 is now about cost. So everything above here has to do with benefit. We're now going to move to the negative externality side. So question 8 says the marginal social cost is the production cost of an additional unit of a good that falls on people other than the producer of the good. So again, I've chosen this question because it's a bit sneaky and requires some good reading. So it says the marginal social cost is the production cost that falls on people other than. So what this statement is actually describing is the marginal external benefit, cost, sorry. So this statement is describing the external cost that falls on anyone else but those who are actually producing the good. The MSC, on the other hand, is this marginal external cost plus the marginal private cost. That would give us the marginal social cost. Okay, so in order for this statement to be true, it should have said the marginal external cost is the production cost of an additional unit of a good that falls on people other than the producer of the good. But because it's referring to social cost, it makes this answer false. If the question had said the marginal social cost is the full production cost of an additional unit experienced by both the producer of the good and those other than the producer, that would be a marginal social cost. So the answer to this question is false, and it just comes down to that word there. Okay. Question 9 then says negative externalities result in, and now we have to figure out, are negative externalities leading to cost being larger than social cost, benefit being larger than social benefit, social cost being greater than private cost, or either A and B are correct? So we can actually draw this graph. So in the case of a negative externality, and for purposes of first year, I'm actually going to draw it below here because there's more space. For purposes of Economics 114, we always treat negative externalities on the cost side of a market and positive externalities on the benefit side. But just know that benefits and costs can be experienced both by producers and by consumers. So if you continue with economics, you will see that you can have costs and benefits on different groups of economic agents. So with a negative externality, what we have is we have demand, which is now the marginal social benefit, because there is no positive externality. Oof, my S came out so bad. Okay, so demand is equal to marginal social benefit, and it's also the same as marginal private benefit because there is no positive externality. Okay, then we have a supply curve which is equal to the private marginal cost of providing this product. So the supply curve represents just the costs to those who are producing this good. And then we have the marginal social cost, which is higher than the marginal private cost because there is this negative externality. So marginal social cost is equal to marginal cost plus the marginal external cost. Okay, so this is a picture that shows a negative externality. What that means is that the market, if it's unregulated, is going to produce here, where only the private benefits and private costs are taken into account. So this will be the quantity that's produced. At this quantity, this value here is going to be the marginal private benefit, and it's going to be the marginal private cost, because that's what the market equilibrium represents. It represents private benefits and private costs being in agreement. But at this market quantity, we see that the true cost, the full social cost of producing this product, is much higher than the private cost because of the presence of this negative externality. So marginal social cost in this market exceeds both the marginal private cost and the marginal private benefit. So with the answers, A says marginal cost is greater than marginal social cost. No, it is the other way around. Marginal benefit is smaller than marginal social benefit. No, as we saw in the picture, marginal social benefit and marginal private benefits are the same. Marginal social cost is greater than marginal private cost. Yes, C is correct. And then D is incorrect, because if A is correct, it cannot be the case that both A and C are correct. So D is wrong. So the answer to this question is C. Now, if we think about this example in the same way as the positive externality, what we can see is that in the case of a negative externality, the market actually ends up overproducing. So this quantity here is what the market produces. This is the efficient quantity. This is the quantity that represents where MSB equals MSC. So because of a negative externality and no regulation in this market, we end up with a deadweight loss. And as you can see, this deadweight loss lies to the right of the efficient equilibrium because it represents overproduction. And that's different from the graph above, where the deadweight loss lay to the left of the efficient equilibrium because a positive externality led to an underproduction. So you just have to be careful about where the deadweight loss is and making sure that you put it on the right side of the efficient equilibrium. Okay, so question 10 is about Coase theorem. Basically, what he wanted to illustrate is that when you have these negative externalities in society, they can actually be corrected by the market. So sometimes when you have these costs that fall onto people other than those who are directly producing the product, because costs are something which we experience far more heavily than benefits. If you ask anybody, they'll be able to remember things that were bad in their life more easily than things that were good. We do tend to put more weight on losses than we do on gains. So because we actually do, in our personal capacities, try to account for these costs that are indirectly placed on us, the market is then able to take them into account. And we may not then need government regulation. So Coase came up with this idea, which is very neat. However, it does rely on 3 conditions. Coase theorem is only going to result in an efficient outcome without government intervention if property rights exist. Okay, the only way that you can hold somebody accountable for damage caused to you or your property is through being able to prove ownership over that thing. So property rights need to exist in order for Coase theorem to work. The number of people involved or parties involved needs to be small, because otherwise negotiation can get very messy. And transaction costs need to be low. So the transaction cost is any sort of cost, whether it be explicit or implicit, that is involved in that negotiation process of trying to hold somebody accountable for causing you a cost without you being directly involved in production or consumption or any kind of market transaction. So these are the three conditions that need to hold for Coase theorem to work. So the answer to this question would be C. So C fulfills the definition of Coase theorem. It says that the Coase theorem states that externalities can always be eliminated by the market as long as property rights exist. So B immediately falls out of the picture because property rights have to exist. Number of parties involved is small. So that immediately eliminates A because A says large number of parties. And transaction costs are low. So that immediately eliminates D because even though the first two statements are true, transaction costs should not be high. So the answer to question 10 is C. This is a really typical sort of theoretical question that comes up either as a true and false or a multiple choice like this, or maybe even a quick little 2 or 3 mark question in the descriptive part of the assessment where we ask you to discuss the Coase theorem. Okay, so this question I think relates exactly to what was asked by P. Stansfield earlier. So in this question, what we're going to actually see is how government works out that subsidy according to the marginal external benefit. So we have this table that shows costs and benefits arising from university education. There is no government intervention. So that's important because it tells us that this market for university education is unregulated. Universities are competitive. So the way in which this market is going to provide education is going to be according to just the private benefits and costs of those directly involved in the production and consumption of education. So question A says, how many students are enrolled at universities and what are the tuition costs per student per year? And this question you need to answer keeping in mind that this is a competitive market. So the market is only going to take account of the private benefits and the private costs, which in this case is also the same as the social cost because there is no negative externality to the provision of university education. So the market is going to want to find the point at which the private benefits and the private costs align. And in terms of the graph, that is finding this point here, okay, where MB equals MSC. So the table and the graph are essentially the same thing. So where MB equals MSC is at 16 million students and 10,000 Rand per year. So the answer to question A is 16 million students will be educated. 16 million students enrolled and tuition will be 10,000 Rand per year. Okay, so that's very simply just finding demand equals supply. B then asks, what is the efficient level of enrollments, and briefly explain. So efficiency has to do with finding where MSB equals MSC. So what we have in this picture is we have the private benefit and the external benefit. So the social benefit is going to be these two values added together. So when 4 million students are enrolled, they experience a benefit of 16,000 Rand each. However, they generate an external benefit of 8,000 Rand. So the marginal social benefit is 24,000 Rand. At 8 million students, the marginal social benefit is 21,000 Rand. At 12 million, it's 18,000 Rand. At 16 million, 15,000. At 20 million, 12,000. And at 24 million, 9,000. So the MSB is simply calculated by adding these two values together. So to find the efficient level of enrollments, what we need to say is it's going to occur where MSB equals MSC. So that's the brief explanation. Efficient enrollment will be where MSB equals MSC. And in terms of the picture, I can see that MSB of 12,000 equals an MSC of 12,000 at 20 million students. So the efficient level of enrollment is 20 million students. So I'm just going to put the efficient in a different color. So the efficient quantity is 20 million. And in order to provide this quantity, we're going to have to charge a tuition of 12,000 Rand, because that is what it costs to provide that amount of education. So in C, we then ask, if the government wants to achieve the efficient amount of education, if we want to increase education from 16 million to 20 million, how much of the tuition fees are paid by the government and how much are paid by the student? So if 20 million students go to school, we see that the 20 millionth person values their education at 8,000 Rand. That is how much they are willing to pay, because that is the marginal benefit they personally extract from education. However, they generate an additional 4,000 Rands worth of marginal external benefit. That means that universities have to charge 12,000 Rand because that's the cost they need to cover. But students will be responsible for 8,000 Rand of the tuition because that is what they are able to pay. And governments will cover 4,000 Rand of the tuition cost, because that is the difference between what society needs to pay and what those who consume education are actually able to pay. So I'm going to relate this table back to the picture from earlier. So imagine that this is the 16 million students that are being educated by the market without regulation, and this is the 10,000 Rand that is being charged. What we want is for the market to be providing 20 million students with education. However, in order to do so, they're going to have to charge 12,000 Rand. So if I add the values into this picture, this is 12,000 Rand. This over here is 10,000 Rand. This is 16 million students. And this is 20 million students. So that's what the table kind of suggests. If we go back to the table and we look at how much private consumers of education value 20 million students being enrolled, we see that the 20 millionth student has a marginal private benefit of 8,000. So this number on the graph here, this value at 20 million and the demand curve, that number there is 8. Okay, so universities need to receive a full cost of 12,000 Rand because that is what it costs to provide 20 million students with education. But each individual student is only able to afford 8,000 Rand. And that means that this difference here of 4,000 needs to be covered by government. And that 4,000 Rand could be covered through a subsidy directly to the university, or it could be covered through giving 4,000 Rand directly to students and saying to them that this is a 4,000 Rand bursary that has to be used towards your tuition fees.